Hey guys, welcome back. In the previous video of this series where we are assembling the TV typewriter, we assembled the mainframe board of the project and tested it out by connecting this antenna wire to a TV, and it was showing a black screen, which is exactly what we were expecting. So I'm going to put this board aside for now since we don't need it for the moment. And I'll bring in the timing board, which is the next board that we're going to install or assemble, and then try to insert it into the mainframe and test it out. We already installed the connectors in the previous video. We actually did it for all the boards, so that's finished. And we can reference the parts list of this construction manual. So this is the parts list for the timing board. So I think I got pretty much everything that I need for the assembly of this board right over here. We will continue referencing this construction steps that we actually started in the previous video. I think we left off on step number 3, where we tested the TV screen to make sure that it was actually black screen and no audio. And now we're going to move on to number 4, where we're going to start building the timing board. So as I mentioned in the introduction video, I couldn't find the 4.561.920 kilohertz crystal oscillator here. It's an interesting number. By the way, that comma should be a period. So it's 4,561.920 kilohertz. I couldn't find that specific one, and I think these specific frequencies were actually used in television sets back in the 1970s, so they were probably more common than they are now, and which is probably also the reason why it was chosen. But since I couldn't find one, I think like I haven't really tested this yet, but I think a 4.5 megahertz crystal should still work. It's slightly off by 61 kilohertz, but we'll see. If it doesn't work, we'll figure out a way to fix it. Okay, so let's start the assembly. The assembly is pretty straightforward. There are quite a bit of jumpers here, which is the first thing we're going to install right now. So we'll install all the jumpers, and then we will move on to like resistors, ICs and capacitors, and also the crystal, and that's pretty much it. Like, there isn't really much to this board, so let's go ahead and install the jumpers and then move on from there. Whew, that was actually a very time-consuming process installing these jumpers. So what you just saw in a few seconds actually took about an hour to complete. But I think we got all the jumpers installed correctly. I can double check later again off screen just to kind of make sure that everything's soldered in. There are no cold solder joints and no miss solder points, but as far as I can see, I think this is pretty good so far. The next thing we're going to do is install the resistors. Well, actually, never mind what I said, because it looks like I actually missed a jumper right here. So let me go ahead and install that as well. Yeah, I think all the other jumpers have been installed correctly. I did a second pass just to make sure, and it looks correct to me. All right. I guess the next thing we're going to do is install the resistors. So let's go ahead and do that. And we can reference the parts list as usual. So let's see, R1 is 330 ohm. R1's right here. And then R2 and R3 are 220 ohm. And unfortunately, I don't know, I can't find the 220 ohm carbon composition resistors. So I will actually use these modern ones that I have in my big set of resistors. So that's R2 and R3. Really like how the traces came out on these boards. They look nice and crisp. Because usually whenever you you know, convert the artwork from like old articles into like a digital format, the traces are not as clean. But these seem pretty nice. Okay, so these are the resistors. We're finished with those. I think there were only 4. So let's go ahead and install the IC sockets. So it looks like we have, what, 9 sockets? No, we have 12 sockets actually. And they're all 14 positions. So I'm going to use these 1970s version. I believe these are 1970s if I'm not mistaken. Made in the United States. Yeah, so if these are made in the US, they're pretty old, because most of the modern ones are actually made in China. And I don't know how reliable these will be, but we'll see. Actually, when I use these sockets for the encoder of the keyboard that I built in a previous video, they work pretty well, so no complaints yet. Okay, let's just go ahead and install all of these. And it looks like all of them face down, so pin 1 faces down. And those are the IC sockets. Let's now install the ceramic capacitors. So we have 4 0.1 microfarads, 10 volts. I think I'm using 25 volts here. These are C1 through C4. C5 and C6 are 160 picofarads mica capacitors. C7 is 0.001 microfarads. Disc right over here. One of the pins is actually hidden underneath a jumper wire. Now let's install the electrolytic capacitors. C8 is 100 microfarads, 6 volts. I have 100 microfarads, 6.3 volts right here. Just gotta make sure we orient it correctly. Minus to minus, plus to plus. And C9 is 33 microfarads, and I have 33 microfarads, 50 volt. It actually calls for 6 volts, so this should be sufficient. And one thing that I just want to show you quickly is like if you look at the board like this, you can see that it's not actually flush with the connectors here. Basically, these components here, like for example, the capacitors, are actually protruding past the connectors, which is why I think it's a good idea to have these male connectors be this long and have it be a little higher, because some of these components are just pretty tall. You know, we're gonna basically, if the connectors are short, they're gonna hit against the board above it. I mean, we could just bend the components to make it fit, but I think it's better just to have a little bit more clearance. Okay, let's install the crystal oscillator. I'm going to use a 4.5 megahertz. See, this one is actually, the footprint for the crystal oscillator is pretty big actually. So I'm thinking if I do eventually find the 4.561 crystal, it's probably from back from 1970s, and it's going to be a big one. But these modern ones are actually smaller, so we need to bend the leads a little bit to make it fit. Okay, I think those are all of the solderable components. We're going to go ahead and install all of the ICs here. Since it's sort of hard to see where each IC goes, I'm actually going to use the construction manual silk screen so we can actually see which one goes where. So IC1 is 4024. I think that's the MC Motorola 4024. Okay, so we got all of the ICs inserted. We have to just double check to make sure that they're in the right position and orientation, and that none of the pins are actually bent. We can also go ahead and wash the board of any flux and rosin underneath it. And I just realized that I missed one more jumper right here, right beside this connector. I mean, they're just kind of hard to see there sometimes, so just be careful, double check and see if any jumpers are missing. Okay, so let's double check the board again to see if we missed any holes. So these, the horizontal and the vertical positions, we'll leave unsoldered for now. And these larger holes, and this one right here as well, we'll leave it as is for now as well. I think these are made for testing. Okay, so I think we are finished with the timing board. So we can probably insert it into the mainframe, but I'm not going to do that just yet because we need to, before we can actually go and test the second stage of the TV output, we actually need to populate some parts of the memory board. So we need to populate IC10 and IC11 and the related parts on memory A board, so the first memory board, and then we can do some testing. So let's go ahead and do that. Okay, so with this memory board, we're only installing the C10 and C11 and also a couple of resistors and capacitors that are related to these ICs here. But we also need to install a couple of jumpers as well. And I'm thinking, if we're going to be installing jumpers, might as well go ahead and install all of them on this board. There's quite a few of them here. So yeah, let's go ahead and install all of the jumpers while we're at it. We'll complete the rest of this memory board in another video, but we'll install the jumpers in this video. Whew, another large set of jumpers that took a while to complete. But I went ahead and installed pretty much all the jumpers on this memory board. So the good thing is that we won't have to install them later once we install the remaining components of the memory board. I didn't install these jumpers on this enable and protect side. I'm not exactly sure what that is just yet, so I just left it as is for now. But once we get to this board, we can install them if necessary. Okay, the next thing we want to install are the resistors. So let's go ahead and install those. Well, while I was recording the installation of the resistors and the capacitor and also the ICs, my camera ran out of storage, so I had to stop it, and actually it stopped on its own, and I had to restart it. So I installed these resistors here. So if we look at the schematic, the resistors that we should be installing for now on the memory board are the R38 resistor, R39, the R36, and R51, and also R43. So there are, sorry, and R44. There are 1, 2, 3, 4, 5, 6 resistors. I missed one, which I'm going to do right now. And also we need to install the capacitor C13, which is a 100 picofarads, if I'm not mistaken, microcapacitor. And then these IC sockets, one is a 14 position and the other is a 16 position, and the IC 7401 and a 74165. So let's see, I think I missed R44 right here, which is 2.2K. So I will install it right now, and once I install it, we can insert this board into the mainframe that we already completed, and then insert the timing board on top of it like this. And the reason why I want the timing on top is because I want to be able to test positions here, if anything, basically. We're testing the timing board right now, so we want to have it on top. So yeah, let me go ahead and install R44 with the 2.2K resistor, and stack the boards on top of each other. Alright, so let's go ahead and stack the boards, and again, I'll be stacking the memory board first, and the boards stack only one way, so if you try to stack it the wrong way, it won't actually fit, or it shouldn't fit. Don't try to force it in too much. But we want to align this notch here on the board with a notch on the silk screen of the mainframe, and it should go in fairly nicely. These Molex connectors are kind of tough to work with sometimes. Alright, so we got the memory board in. Let's get the timing board in as well. Let me just check underneath here, make sure I'm not messing anything up, make sure nothing's bending. Looks good. I think it's in. So this is the left side of it, and also the right side of it. It's kind of hard to see the alignment because of the transformer here, but I think it's pretty good. It has been reported that the original artwork for the PCBs actually were not aligning at all with each other, so it was really a mess trying to fit them all together. I did try to fix that with my PCBs here, just to make sure that they actually align correctly. Okay, so we got them installed. Let's check for shorts on the positive 5 volt positive 5 volt line, as it says here on the number 4 of the construction instructions. Yeah, so the positive 5 volt line is let's see, pins 58 and 59, and also ground. So let's see if there's any shorts between 58, 59, and ground. Actually, 58 in ground and 59 in ground. Yeah, so no shorts. There is some resistance, but that's okay. That's normal, since we have all kinds of components installed so far. Apply power and check for any shorts. I think we should have checked for shorts before we applied power, which I just did, but let's go ahead and apply power and turn on the TV and see what it actually displays on it. So I already have this wire connected to the antenna of the TV here on my side. I just need to turn it on, and let's go ahead and turn it on and see what it shows. Okay, so I just turned the TV on, and it's just a black screen, so I'm just going to turn it off. I think the reason why it's a black screen is because we need to actually set the position jumpers here on the timing board. Well, since we're seeing a black screen as before, I will do some changes just so we can try something different. I will solder in these positions here, basically the V position and two H positions on the timing board. But first, let me remove the board from the stack. I will leave the memory board on there for now. And let me just add some jumpers for the V position and the H positions here. Alright, so after looking over the schematic here, I think we might have missed some components here. So the construction manual here states to install IC 10 and 11 and all the related parts to the memory A board. My guess was that it was only referring to these components here that are connected to the IC, but I think that's actually not 100% correct, because some of the circuitry here is not actually complete. Basically, these ICs are not getting power, so we need to install R7 at least, and also I'm going to install the 1N4001 diodes, and there's 3 of them here. So D2, D3, and D7. R7 is 2.7 ohm, and it goes right there. Okay, got those installed. I think that should be sufficient enough. We're not using the minus 12 volt side yet, so I don't think we need that diode. And also the minus 5 volt, but I thought might as well go ahead and install them. Additionally, I just realized I missed a jumper right here, but I'll install it later. I don't think it's required for this test. Okay, so let me insert this board into onto the stack here. Okay, let's go ahead and power it on again. So let me plug it in. Let's turn the switch on. Okay, I'm seeing a black screen. Let's do some testing to see if we're actually getting correct voltages on the ICs here of the memory board. So pin 16 is positive 5 volts. Yeah, we're getting 5 volts there. Well, almost 5 volts, 4.84, which is pretty close. Okay. I'm just seeing a black screen again, so I'm curious why it's doing that. Well, while I was testing these test points on the timing board, I realized that I missed a jumper here. So these jumpers, there's just so many of them, it's fairly easy to miss them. So whenever you install them, just double check, triple check, just to make sure you install them all. I actually thought that J was for the J test point or something. Also, this, I don't know if that's an F or what, but it's backwards. That's interesting. Anyway, I'm gonna go ahead and install this jumper. Okay, the jumper is in. Let's reinsert the board. Actually, you know what? Before I do that, this crystal, I think we want to connect the case of it to that position, that hole right there. So let me just go ahead and do that. I think that's basically to reduce noise. So let me solder in a piece of lead. So I got the jumper soldered in, and now I want to test it out, see what it's going to show. And let's take a look. I'm going to turn the TV on. Okay, let's turn on the switch. Okay, so it looks like we're getting some data. So what we were supposed to be getting is just rows and columns of squares, white squares, and that's actually what it looks like we're getting. The only thing is that it's not, first of all, it's not aligned. It's slightly lower than it should be. I think we can probably adjust the screen on the back of the TV. I'm gonna try to do that. But I think if that doesn't work, we can also change the jumpers on the timing board. Basically, I think that's the vertical position. So we can like try different combinations of jumpers, different options, and see which one works better. But I'll probably do that later. This is actually a pretty good test already. One other thing that I'm seeing is that it's a little fuzzy, like between each square and the white square, it's like blinking. It's not clean squares. So I'm curious right now if maybe it's a problem with the TV, maybe the RF modulator or something like that. So I'm gonna hook up the TV typewriter to an actual composite video monitor, just so we could actually test the actual composite video to see if maybe it's the TV or not. Okay, so I hooked up the same monitor that I used for the Apple One to this TV typewriter, and the way I connected it is basically I used this composite video cable, and also I used Apple One's composite video connector here, the RCA connector, and I connected it to a TV typewriter, and the outer portion is connected to the ground, and the inner pin of the composite video connector is connected to pin 20 of the bus here on the TV typewriter. And that's how we get composite video from the TV typewriter. And the data that we're seeing, so it's a little bit cleaner. I think we can still make some adjustments to it. It's not as wavy, but it's still not crisp. Basically, if you look at between each column, it looks like it's just kind of scrolling or something. So I don't know what's going on with that. I think that it could be because of the crystal oscillator that we're using. It's just off. So I don't know. We'll have to investigate and find out. I think I will probably just leave it like that for now and continue building the remaining components of the TV typewriter. And then I'm going to try something that either basically replace the crystal oscillator with the correct one, if I can actually find one, or make a circuit basically to change the frequency of the oscillator to be the correct one. So yeah, we're gonna have to play around and see what happens. But for now, I'm gonna leave it put it on hold. I went ahead and installed a tremor capacitor, which was the same one that we used for the TV tuner here. I think it's a 3 to 30 picofarads capacitor, and I installed it in series with the crystal. Basically, I cut one of the leads of the crystal and then connected the capacitor in series, and I tuned it slightly to to change the frequency, and this is what we're seeing on the screen now. So the white boxes are pretty clean now. I think the frequency of the TV typewriter is close enough that the display on the screen is much better. I don't know if it's 100% correct yet or clean yet, but it's much better. Plus, it's a little bit misaligned, and I think it's because of the vertical and horizontal position jumpers here, but I'll fix that later. But yeah, that looks much better. So yeah, if you can find a crystal that is 4.561.92 megahertz, so use a different crystal and just add a trimmer capacitor to change the frequency slightly. It might be better to use a higher frequency, let's say 4.6 megahertz, and then use a trimmer in parallel with the crystal, which will be a little bit cleaner than doing it in series when it's a smaller or slower frequency. And I use my oscilloscope to kind of help me fine-tune the frequency of the crystal. I'm going to go ahead and hook up the actual TV that I was using and see if it shows the white box is a little bit cleaner than before. I went and hooked up another TV that I had. This one has a smaller screen, and this one is showing the squares a little bit better. They're much crispier than the other TV. The other TV seems to be distorting the image for some reason, just slightly. This is pretty straight. The vertical and horizontal positions are slightly off. This TV doesn't even have horizontal adjustment. But yeah, I think this looks pretty good. Well, I hope you enjoyed watching this video. In this video, we completed the timing board and part of the memory board and got the squares on the screen, which is a big step forward. In the next video, we'll probably assemble the cursor board. I think that's the next step in the process. And then the memory board. Well, thank you for watching. Don't forget to like and subscribe, and I'll see you in the next one.